So compute the midpoint, trapezoidal, and Simpson's rule. Approximations of integral 0 to 1, 4 over x squared plus 1 dx with n equals 10. So can you tell me here, how are you going to use midpoint rule approximation? What is the rule for midpoint? Heba?
Yes, you find like the points that you're gonna use as x. So x0, I mean, like between x0 and x1, and then x1, x2, all this, and then you've put that in the equation, and then you times it all by delta x.
So yeah, actually we say here for the midpoint rule, we say from 1 to n f of ci times delta x, right? Sum of them, sigma notation.
Yes.
But the question comes to mind here, what are these points, ci? How are we going to find them? Any ideas? Sarah?
Ci is a plus delta x over 2.
Yeah. Yes, we're going to use that. But first, we can say it is the previous point plus the next one over 2, right? So first, let's find delta x. Let's find delta x first. What is delta x here?
b minus a over 2, which is
B
1.
minus a. First, let's mention this is the a and this is the b, right?
Yes.
B minus a over n, which is 10.
Yeah,
So
1 over 10.
1 over 10. So we're going to start from 0, right? Then next going to be 1 over 10. Then 2 over 10, which is 1 over 5. 3 over 10. 4 over 10, which is 2 over 5. It keeps going like this, right? 5 over 10, 6 over 10,
L 1.
7 over 10, 8, 9, and 10 over 10, which is 1. Here we consider this point as x is 0. This is x1, x2, 3, and the last one gonna be x10. So these are x points, not the ci. For the midpoint rule, we're gonna find c1, and c1 is, as you know, it is here, right? Between x0, x1, between x1, x2. It is the midpoint of x0, x1, x1, x2. So let's find the C1. So C1 gonna be 0 plus 1 over 10 over 2, which is 1 over 20, right? Correct?
Yes.
Yes.
If you wanna find, this is C1. If you wanna find C2, we're gonna say C1 plus delta x, right? It's the easy way. Is that correct?
Yep.
Yeah.
So the next one gonna be 1 over 20 plus 1 over 10, which is 3 over.
3 over 20.
So there's a sequence here. Denominators are equal and numerators are increasing by 2, right? 1, 3. Then next one gonna be
5 over
5.
20.
The next one gonna be
7 over 20.
then
9.
then
11.
yes,
13, 15.
17 and 19. You're gonna stop here. I need 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So this considered as C2. This is C3, and the last one is C10. So far, what did we do? We got delta x and we got evaluation points C1 to C10. So what we're gonna do here? Since we know midpoint rule says sum of f of ci, sum of them multiplied by delta x. So I'm gonna write here f of c1 plus f of c2 plus until the last one, which is f of c10, and I'm gonna multiply them all by delta x, right?
No, 10.
And it is given to us 1/10.
Yes.
So let's do this work. What is f of c1?
It
Oh.
is, I think,
Wait.
3.99.
Let me write here what is f of x. You know f of x is 4/x squared plus 1, right?
Yes.
So you can do this. Of course, you can take 4 outside of the bracket, but not necessary. You're gonna write 4, and instead of x, you're gonna write c1, which is 1/20 squared plus 1.
3.99. For that one.
At the end, you can write all in the calculator. You'll get more accurate answer. So the second one gonna be 4/3/20 squared plus 1. It keeps going like this until the last one, which is
4/19/20 squared
19/20 squared plus 1
times
times
1/10.
1/10. If you use your calculator and calculate this one, the answer you gonna get is, approximated one is 3.142425985. Any questions?
No.
So this is the midpoint rule. We're gonna do same work means, but by using different rule to approximate the second one, which is,
Trapezoidal rule.
yes, let's do that. So let's call this one midpoint rule, M10. 10 means n is 10, okay? So let's check the second one, and let's call the other one T10. So this is gonna be approximately, but first I have to write the rule for this one. What is the rule for trapezoidal approximation?
B minus A over 2n multiplied by a sum of
Yes, f of
f of
x0
x0 plus 2 f of x1 and so on until f of x10.
until the last one. Let's write here 2f of xn minus 1. X minus 1 is 9, right, for us?
Yep.
Okay, let me write n minus 1 plus f of x n. Okay, we can write n. Let's erase this and rewrite 10. So for our question, b is given. What is b?
1,
Minus
0.
0.
over
2 times 10.
20.
x0 is given to me in the previous slide. We got x0, which is 0, right? This is x1, x2, x3, all of them written here. So I'm gonna write here 0 plus 2 times f of
1
what is
over
this?
10.
1/10.
It keeps going like this, right? And like this is 9/10, right? 2 times f of 9/10. And the last one is 10/10, which is 1.
1.
Perfect. So we're gonna calculate this one. This is 1/20. And f of 0 means you go to function. Instead of x, you're gonna write 0, right? Here is our function, 4/x squared plus 1. So this is gonna be 0 squared plus 1. The other one gonna be 2 times 4 over 1 over 10 squared plus 1. It keeps going like this. I'm gonna write the last one here. I skipped this all. The last one gonna be 4
over 1 square plus 1.
plus 1. If you use your calculator, the answer you're gonna get here is 3.139925989. So which rule is this one?
Trapezoidal.
Yes. So one left, which is
Simpson's rule.
Simpson.
Simpson's rule. Let's represent this by S, 10. Can you tell me the rule for this one? What was the formula?
B minus A over
Delta x over 3.
3n, right?
Yeah,
Yes.
Yeah.
3n.
F of x 0 plus
4
F
Or f of x1
plus 2
to f of x2.
plus,
4
it keeps going like this. Then 4 f of xn minus 1 plus f of xn. So what we know here is, if the coefficient, the first and the last, they don't have their coefficients are 1, right? Not 4 and 2. Then others, if it is odd number, this index, coefficient is 4. If it is even, it is 2. It goes like this, right?
yes
So let's use our formula. What is B?
1,
Minus
0 over 30.
13. F of x0, just I wrote here, which is f of 0 plus 4 times f of 1 over 10 plus 2 times f of 2 over 10, right? Which is 1 over 5. Plus, it keeps going like this. You can write them all. Just I want to skip this part. The last one before the last one is 4 times
9 over 10.
9 over 10 plus f of
1.
1.
So, of course, you know what to do. Instead of f of 0, you're going to write 4 over 0 squared plus 1. 4 times 4 over 1 over 10 squared plus 1. It keeps going like this, right?
Yes.
And
Yes.
for the last one, you're going to write 4 over 1 squared plus 1. This all multiplied by 1 over 30. And if you use your calculator, the answer you're going to get here is 3.141592614. Any questions so far?
No.
So we solved the same question by using 3 different approximations. Let's write them all here again. For n equals 10, by using midpoint, we got the answer 3.142425985. For the trapezoidal rule, we got 3.139925989. And for the last one, we got 3.141592614. So how do you know which one is more accurate?
We check the error.
We're going to check the error, right?
Yes.
Let's write your error. What is the error? How do we find error?
The exact answer minus the approximated answer.
In the absolute value, exact minus approximated one. So let's find exact answer for this question. So our question is 0 to 1, 4 over x squared plus 1 dx, right?
Yes.
So this can be written as 4, 0 to 1 over x squared plus 1 dx.
4 tangent inverse
Yeah, this is 4 times tangent inverse
x.
x 0
Then-
to 1, then 4 tangent inverse 1 minus 4 tangent inverse 0.
We got
And
both.
answer
Pi.
is pi. So if you look at here, if we say pi minus this one, the answer you're gonna get here is 8.3333 times 10 to the power negative 4. For this one, if you do same work, you get 1.66. You have 5, 6 here, times 10 to the power negative 3. Then for the last one, you will get 3.95898 times 10 to the power negative 8. So this negative 8 means error is that much smaller, right?
So the best
So-
one is the third one.
Best one is
The third one.
the third one, Simpson's. Okay, the error here is less than other two. If this is the so far the best one, if we compare for n equals 10, how about other two? Which one gives better approximation than other one? Midpoint. Midpoint, right? Negative 4. Less you can say this is the first, then this is the second, and this is the third one.